Okay, so this video is meant to introduce you to the idea of the Doppler effect. And the Doppler effect is a difference in the perceived frequency of a sound, or of a wave, so difference in the perceived frequency of a wave due to the changing distance between the wave source and where the wave is detected. Due to a change in distance between a wave source and where the wave is detected. And something to note is that it's a perceived shift in frequency, so the actual frequency does not change. It's just that the listener or the receiver of the wave perceives that it's a different frequency, but the source has not actually changed the frequency value. So if we were to look at the two examples of how you'd have a Doppler shift, one is if the distance is decreasing. And so the distance between the source and the detector would decrease if the source was moving towards the detector or the detector was moving towards the source. So if the distance is decreasing, then the same amount of waves must fit in a shorter distance. So the waves are compressed together. Let's not say shorter, let's say in a smaller distance. So the waves, the consequences, the waves are compressed. And the perceived frequency is higher. So that if the distance is decreasing. The opposite can be true in that if the distance is increasing. And so when would the distance be increasing? The distance would be increasing if the source was moving away from the detector or the detector was moving away from the source. And so in this case, the distance between the source and the detector is getting larger. And so the same amount of waves now has to occupy a larger space. So the waves get stretched out and the perceived frequency is lower. Doesn't even look good for frequency. Frequency lower. And that kind of makes sense. The classic example of the Doppler effect is like the ambulance or the fire truck that's coming at you, and as it's coming at you, that distance is getting shorter, so the perceived frequency is higher, and then as it's going away from you, that distance is getting larger, and so that perceived frequency is a lot lower. Okay? So let's look at the actual equation for the Doppler effect, and this is the general equation for the Doppler effect, and it can be for if an object is going the receiver is coming towards or away, or if the source is coming towards or away. and we will look at kind of what happens with the sign values. So the equation is that here we are. F prime is equal to F times V plus or minus VO over V minus plus VS. So that's a little different notation. And so let's just kind of talk about what the quantities are. So F prime is the perceived frequency. F is the actual frequency. So this is the frequency that the wave is initially emitting. V is the speed of the wave. So if it's a sound wave, that speed is going to be 343 approximately. If it's a light wave, that speed is going to be 3 times 10 to the 8th. Now VO is the speed of the observer or the detector, and then VS is the speed of the source. And sometimes it's going to be where just the observer is moving or just the source is moving, and sometimes it could be where they're both moving. So you really have to kind of know what speed is associated with what object. Now let's talk about the plus or the minus. In this case, this plus minus, okay, for plus minus, plus means if it's moving towards, and minus means moving away. So if your object is moving towards your source, then you're going to do a positive. If your object is moving away from the source, you're going to do a negative. And that kind of makes sense. Now this bottom one's a little trickier. It's still the same order, but this time minus means moving towards, and plus means moving away. So the way I remember it is that it's just towards, away, okay? And you've got to be careful with that notation. But if you remember just conceptually that if that distance is getting closer or that distance is getting smaller, then the frequency, we should hear a perceived frequency of a higher pitch, or we should have an increase in frequency if it's a light wave. And that if that distance is getting bigger, then that perceived frequency should be lower. Okay, I should have a lower frequency value. So when you get back into class, we are going to do some examples of the Doppler effect, okay?